We're going to work problem 16 on problem set 3.9a. We're asked to prove that this implicit equation, when we differentiate it, would be equal to that derivative. So let's go ahead and start that. Let's take the derivative of x, which is 1, times y squared using the product rule. Then we'll add x times 2y, y prime, minus 3x squared, y minus x cubed, y prime is equal to 0. Let's collect our y prime terms and factor out accordingly. So we'll have 2xy minus x cubed times y prime, and then that will be equal to, we notice we have a negative 3x squared y, so we'll bring that to the right side, and that'll be a positive 3x squared y. And then we have a positive y squared, and that will become a minus y squared. We notice that we pretty much have the form of our answer. All we have to do is divide both sides by this factor, and we'll write our answer now in dy and dx notation. And we have proved that, in fact, it is valid. Okay, next part of our problem asks us to find all the points on the curve whose x-coordinate is 1, and then write an expression or an equation for the tangent line of each of these points. So let's go ahead and first find out where the points would be. Let's use 1 for x into our original implicit equation, and we'll have 1 times y squared minus 1 times y is equal to 6. And if we then write that as a quadratic, we notice that we can factor it. 2 factors, y minus 3 times y plus 2. And we notice then using the point x is 1, we got the points 1, 3, and we've gotten the points 1, negative 2. So let's determine what those slopes are at those points. Let's start out with 1, 3. So we're going to find the slope of the curve at 1, 3. In doing that, we will just substitute those values into our slope equation. And that would be 3 times x squared, which would be 3 times y, which would then be 3, minus y squared, which would be 9. And then we could put that over 2 times 1 times y would be 3, and that would be minus 1 cubed, which is 1. We notice on the numerator we have 0, and we have a 2 on the bottom, so our slope is equal to 0. So we have a horizontal line slope, and the equation for that would be y is equal to 3. So that's our first answer there. Now let's determine the slope at the point 1, negative 2. So we'll substitute into our slope equation above. We get 3 times 1 again is 3 times negative 2 minus, then we have negative 2 squared, which is 4. And let's put that over 2 times 1 is 2 times negative 2 is negative 2 minus, and then we have 1 cubed, which is minus 1. And I'm left with negative 10. I'm sorry, we have negative 6 minus 4 is, oh, I'm sorry, I forgot a 2 here. 2 times 1 is 2 times negative 2. There's a 2 here in the denominator. So we have negative 10 in the numerator, and then in the denominator we have negative 4 minus 1, which is negative 5, leaving us with a slope of 2. Okay, writing the equation on point slope form using 1, 2, we would get y is equal to the slope, which would be 2 times x minus 1 minus 2. So there is going to be our second slope equation. Okay, finally it says find the x-coordinate of each point on the curve where the tangent line is vertical. We examine vertical tangent lines when the slope is going to be then 0. So we're looking at the expression 2xy minus x cubed, seeing that when that equals 0, we could then go ahead and factor out an x, and then we have 2y minus x squared equals 0. So one possibility occurs when x is 0. So let's examine the equation then and find if that point with x is 0 is on our curve. And we notice that 0 times some y squared minus 0 times some y would never be equal to 6, because 0 minus 0 can't equal 6. So this candidate, x equals 0, we would then eliminate. So now we're looking at possibilities where 2y minus x squared would be equal to 0. And I'm going to go ahead and solve for y then, so I can figure out what x's would be valid. And y would be equal to x squared over 2. So I'll go in now and check to see what that coordinate might be by substituting that in the original equation and see if that's valid. And I have x times x squared over 2 quantity squared minus x cubed times x squared over 2, and we're going to see when that equals 6. So this first expression would be x squared over x to the 4th over 4 when I square it. So times x is going to be x to the 5th over 4 minus x to the 5th over 2, x to the 5th over 2, and that's equal to 6. You notice I can go ahead and then use a common denominator, and I'll notice that these are 2 over 4, and so I get a total of a negative x to the 5th over 4 is equal to 6, and so therefore x to the 5th, negative x to the 5th is equal to 24, and then x to the 5th is equal to negative 24, and since I could take the 5th root of both sides, which would leave me x is equal to negative 24 to the 5th root. And that should be our final answer then. And so that's the x coordinate, and that takes care of that problem.